for my presentation, I decided to talk about what is COVID, how bad is it, does it compare to other experiences I've had in my life, and most importantly, how can I predict what will happen? So, first of all, this is not my first outbreak. This is the worst. This is the craziest, but it's not the first outbreak I've experienced in my life. Most of my experience has been through watching what's happened in other countries, because it didn't seem to affect us quite as much here, and also just through the news. I would say that the one that affected me the most probably was swine flu. I was teaching by that point, and we were a little more paranoid about where we took students, what we did. I was working for a boarding school at the time, of which about 40% of our students did come from Asia, which had been hit harder than we were. And the biggest change to my routine was just we had to clean our classrooms more. And they gave us hospital strength cleaners and had us scrub down between classes. But beyond that, it didn't really affect me. So I know all of us have our own personal reasons for why COVID is such an issue. And for some families, it's not as big an issue. I know for me, many of you know I just got married 3 years ago, and we are, for my family, we want to be a little more paranoid. I put here a picture of a normal lung versus an asthmatic lung, because that's something that we deal with in our family, that makes COVID a little more serious for us. Now, what I started doing is probably back in about April, I would say, I started to pay attention to how many cases do we have, especially when we hit our first 1,000,000 cases. And I got in the habit of just Googling how many COVID cases do we have. So this was a screenshot from a few days ago. You can see here at that point in time we had 5.79 million cases, and at that point in time we had 178,000 deaths. That's the M stands for million, the K stands for thousand. And you can see their own statistics of how many positive cases were we seeing each day. So you can see, for example, on July 25th, there were 65,944 positive cases reported. And then the bubbles over here on the side are just pointing to how big is the outbreak at each location compared to other locations. And one of the most important things in a situation like this is to look at the sources. And I recognize that the source here is Wikipedia, and you can click on the Wikipedia source to see where they're getting their information. Wikipedia, again, not always the best source, but when I looked at my sources, I did compare what I saw to other locations as well. For me personally, I went to the CDC website, the Johns Hopkins website, and the Worldometer website, and I would compare and see. And all of these I took screenshots of what they said at the same time, and you can see there are differences between them. Personally, the one I like the best is the Johns Hopkins website. I like I like their data the best, but it's also the most difficult to read, I would say, and you sometimes have to go searching for the information. And with the CDC, I know that it looks like the others are over-reporting, but what I understand, and I might be wrong on this, but what I understand is that the CDC is just a little bit behind the others in terms of getting the data. Maybe a day or two. So, what I started doing is I started recording when we hit each of our first 1,000,000 cases, second 1,000,000 cases, third 1,000,000. We'd already passed those days. We already had 4 million by the time I started this project. And it was really easy. All I did was I looked up newspaper articles that told me when we hit the first 1,000,000, second 1,000,000, etc. And from that point on, every couple days I started recording how many cases the Google website was saying we had that day. Now, from that, what I saw, as you go back, if you know stats, something that hopefully you would know is this R-squared value tells you how strong your graph fits your data. And the closer that number is to 1, the stronger the fit. So here my r-squared value is 0.9957. So that means it's a very, very strong fit that this equation, a times b to the x power, where a is a little more than 164,000, b is 1.01 blah blah, that right there is a pretty good fit for this data. And it was scary because that's an exponential function. Exponential functions, once they start growing, they start off slow, but then they start growing super fast, really steep slope. So as we went on, I did start to realize, though, that exponential functions assume you're going to grow forever. And there's a function you probably haven't been exposed to yet called a logistic function. And with the logistic function, it does assume you're going to cap out, that there will be a maximum where you will stop growing. So this one I will say I had to look up, and it's this equation right here with the g over 1 plus f times e to the d times x sub 1 power. Took me a while to put that one together, but as you can see here on my graph, as I started plotting slowly, eventually I started plotting every day, I could see that it was fitting this graph very, very strong. And again, the r-squared value on that is 0.9977. Super strong correlation. So if I go back, one thing I want to point out is I use the exponential function to predict when we'd hit each of our next millionth cases. And I will say the 5 millionth case, I was pretty close. I really was very, very close. I think I was within like 2 days of when we actually hit 5 million cases. But I am very, very happy to say that, as you can see from the real curve, we have slowly started to flatten the curve a little bit. And I had originally, with the earlier prediction, sorry, let me get that back. I had predicted we'd hit 6 million cases on August 18th, and then in just a couple of days we'd hit our 8 millionth case. On Wednesday we'd hit our 8 millionth case, but we only just yesterday hit our 6 millionth case. So we can see that we are starting to slow down the curve a little bit. So using this, my newest prediction is that on the 267th day of the year, roughly, we are going to hit our 7 millionth case if we keep following this trend. Now, the trend does change every time I put a data point in. These lines physically do change their location every time I put in a data point. But this is saying that approximately the time we have parent-teacher conferences, this graph is predicting that's when we'll hit the 7 millionth case during that week. Now, my hope, my strong hope is that it's even longer than that. As we slowly started to flatten the curve, I want you to see up at the top here, I have this red line. When I first started doing the logistic curve, my logistic curve, this black line here, it topped out at 12 million cases. Now it's topping out at about 8.5 million cases. So as we flatten the curve, we're going to see less cases. And from what I've been able to calculate with the death rate, if I just take the number of deaths total divided by the number of total positive cases, and this is for the whole year, I'm getting that for every million cases, we have roughly 30,000 people that pass away. So the more we can keep this number down, what makes sense to me is that's saving a lot of lives. And that would be the hope as we go. So where do we go from here? Realistically, this is where personal opinions and personal behaviors are going to play a part. What I see is that we've changed, something changed because we left the exponential growth and we started to flatten the curve. And what changed? I think probably our own attitudes have changed. I think probably what stores and businesses and schools have expected of us have changed. How are we going to use that change? That's going to be up to each person as an individual. So this video, My recording I've got is roughly about 10 minutes. Now I know this is just one person as an individual. You're going to be making a video based on how many people are in your group, and you'll be splitting up the work in whatever way makes sense to you. And I am going to have you judge your teammates based on how much work they put in. But for me personally, I chose to do this as a PowerPoint. You can choose to do this as a face-to-face presentation. You could choose to do this as an animation. However you want to get your point across. I want you to take whatever question your group has decided on, and I want you to create your own video that is going to explain your scientific process. And again, I cannot stress this enough. I do not care what your answers are. I want to know, how did you arrive at your answers? And if you're telling me you just use Google searches, or if it's obvious to me you just used some internet search, you will get marked down on this assignment. I want you to be using some reasoning method to come to your own conclusions. Now you can use Google searches to get you there. Obviously you saw I did. But at the end of the day, I didn't let the Google and the news articles that were out there tell me what conclusions I should draw. I drew them for myself. That's what I want from you. If you have any questions, that's what today and this week are going to be about, is creating your video and creating your process. So if you have any questions, please, please, please let me know.